Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is longest common prefix. So let's go to LeetCode. Write a function to find the longest common prefix string amongst the array of strings. If there is no common prefix, return an empty string. And yeah, that is the entire problem. It's a really easy problem. So what do they mean by this longest common prefix? So we will be given a string array which will contain these n number of words. So if n is the size of this string array, now we need to return the longest common prefix. What is that? That is the longest common prefix. It's the common string or substring that is present in the beginning of all the numbers, and we have to select the longest of that string. So basically, if you see in this example, right, if we go over, let's say, is f present in all the words? F is present in all the words. Yes. Is L present in all the words? Yes, L is present in all the words. Is O present in all the words? O is present in first two, but it's not present in the third word. So that is why it's only two characters that are the common in all the string that's given to us in the string array. So that is why our longest common prefix here would be FL, right? That will be our answer. So this is going to be our answer in this case. So answer. And let's say if we were given just two words. So let's say if this was not part of our array. If let's say this was not part of our array, then what would be our answer? Then our answer would be FLOW right here. So these are, because this entire word is present, right here, right? So that is the longest common prefix in this example. But well, that is not the case. Our current input is right here, right? This is our current input. Now let's solve this. How are we going to solve this? So the best way would be, well, we can make an observation that the answer would never be, the longest common prefix would never be bigger than the shortest or smallest string in this array, right? So if I see, my answer would never be bigger than this. So that is why the first thing that I'll be doing is sort string by length of words. All right. So after sorting this, what I'll be getting is so sorting str by length will basically bring the flow at the first position because it's the smallest, right? And then these two are same size, so we can just put them like here. All right. So flow, flower, and flight. Now, how do we find our longest common prefix now in this sorted one? So what I'll do is I will take the smallest of the string as my base string. So I will basically assign this value to my base string, right? So I will create a variable called base string. And the reason I'm taking this is, like, this is the longest possible common prefix, by the way. This is possible. It's not it right now, but it's a possibility, because I cannot choose anything else. Like, I cannot choose anything longer that flow in this example, because if let's say if I were choosing, okay, you know what, flower, but flower is of size 5 and this is of size 4. So of course this last character is not going to be present here, so this is not even possible. So that is why I will choose the smallest of the words. So now that I have the smallest of the word as my base string, I will have a variable called, longest common prefix, so LCP, initially empty, but then I will iterate over the words or characters of my base string, and then I'll try to find those in my remaining words. And if I keep finding that particular character in all the words, so just like I will first iterate over f. If f is present in all the words, then I will append that to my LCP. Is L present? Yes, then I will append that to my LCP. So I'll keep doing that. For that, I will be running basically a for loop on all the words of flow, and then I will go over all the remaining words one by one. And if I see a mismatching character, then I can just return whatever the value I have accumulated in my LCP so far. Otherwise, and there is one more thing, it might be happen that if my I is at W, which is going to be 3, and let's say there might be some word that is of length greater than that. So and if I'm checking it greater than that, then I don't need to, because there is no need to, right? I can't look for a word that was present at third at the other following indexes. There is no need for that. So it's going to be super simple, and we can wrap this up. We'll talk about the time and space complexity, but before that, let's write down the code. It's going to be simple. So as I said, let's sort our strings first. So I'll have strings sorted strs, and here for key I will provide length. All right, so this will sort all the string by length. Then I'll get the base string, which will be, I can pick the first very shortest string from the strs, and then as I said, LCP will create our answer. And this is not the best way, let's not have this. Is not a constant, so we'll just say longest common prefix. All right, now let's go over all the I and char in enumerate our base string, right? Base string. So as I said, okay, so what we are really trying to find is we're gonna visit all the words. So for word in I will say whatever is remaining in our strings, starting at after the first word. So we can say like that. So in each word, what am I looking for? At the ith position, I'm looking for basically that character. So there might be two possibilities, that either it's not matching, or I is already basically I is greater than the length of this word, or the length of the word is greater than I. Yes, the length of the word is the greater, because I is going to go up till this smallest possible word's length. So if length word, let me have this. So if length of the word is greater than I, or this word at ith position, this position that I'm getting from the base string, if this is not equals to the char, which is in the base string, then you can just return whatever you have accumulated so far into the longest common prefix. If this this for loop runs, that means I have checked that this particular character that I'm getting from the base string at the ith position is present in all the ith indexes in all the words starting at the index 1 in the strings. So in all the words, other than, of course, it's present in the base as well. So honestly, we don't even have to write this thing. It doesn't create that much of a difference. Otherwise, what we can do is we can append that to my word. So I will keep appending this character to my longest common prefix, and then I can just return in the end as well. So it might happen all the words are same, and you get to this last stage. So this we can do. Okay, so I'm gonna zoom out and let's run this code on our test cases. Okay, and this is going to be an end. This is going to be end because we are actually short-circuiting, because this will always happen. That's why I was not getting anything right here. So we want to check if that word at ith position, and this I think most of the time it should run because we're getting it from the smallest. So I has to be smaller than this word. So this was short-circuiting. So now let's run it. Awesome. Let's submit. Great. So time complexity is going to be big of n into L, where n is the longest, I mean not the longest, the size of strs, and L is the length of longest of the word, or the smallest of the word whatsoever. Worst case the longest, because if all the strings are same, then it doesn't matter if you pick the first one or the last one. And then for space complexity is going to be L, which is the longest word, because you are creating this longest common prefix. And in your interview you can talk about that strings are immutable, and when you are doing this, you are you are again and again you are creating this new memory in the new space in the memory, and then writing this longest common prefix again and again to the new memory location. So rather than that, what you can do is you can create an array, and to your array you can keep appending this dot append. You can keep appending this char, and in the end what you can do it, you can just join all of them together with the delimiter of so you can just do this. You can join all of them. So this will reduce that space and time complexity, I guess, because this will get rid of all that string being immutable problem, and you can return like this. So that will also work, I think. Yeah, that will also work. Well, that solution was also efficient. Doesn't really matter. Yeah, this is also efficient. Okay, so let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem.